Hi everyone, welcome to our new lecture in Computer Science 1, CSE114 at Stony Brook University. Today we will talk about exception handling and text input-output. So let's start. So what exactly are exceptions? Exceptions are unpredicted cases, exceptional cases that occur during runtime, where either a mathematical operation cannot be solved, or we need basically to find an alternative to the execution of the program. So when a program runs into such an exceptional runtime error, the program will terminate abnormally, and it basically exits immediately with a message which basically explains that we have an exceptional case. And this includes, for instance, division with 0, or if we try to access an element in an array with an index that is out of the bounds of the array, 0 to the length of the array. Similarly, if we try to access an element in a string, a character in a string, and that is outside the range of the string, we basically have to capture these exceptions and terminate gracefully. Because when we deliver the program to a customer, the customer is not a computer scientist, and if he or she sees such an exceptional situation and sees a message that makes no sense to a non-computer science programmer, he will basically complain. So what we want to do today is to learn how to handle these runtime errors so that the program can continue to run and terminate gracefully. In some cases, we have to be careful to basically either ask the user for additional inputs until the user enters an input that matches our correct case. But in some cases, we just don't know what to do with the error, so we have to exit, but at least we exit gracefully. So let me show you a simple example that actually has such an exceptional situation. So this simple program basically prompts the user to enter two integers, uses a scanner connected to the system input stream to read the two integers, and then we want to print the division of the two numbers, number 1 divided by number 2, and we want to basically say bye to the user. However, if the user enters 1 and 0, or any other number and 0, so 12 and 0, minus 1 and 0, and so on, there will be an exception triggered. The fact that after the division we have plus or minus infinity, and these are not representable as an integer or as a double. In fact, any infinity cannot be represented in a finite amount of memory. And this is just a simple example. I can show you examples where we try to access an element of an array, examples where we try to get a character in a string and we use a negative index, and so on. So in order to actually understand this better, I wrote the same program that you saw before. Basically, this program creates a scanner, prompts the user to enter two integers, the user enters 1 and 0, and then we want to print the division of these two numbers, the quotient of the division, since these are two integers. However, if the number 2 was 0, no matter what was number 1, this statement will never get executed, basically the by statement at the end of the program. Why? Because the program actually finishes the moment that we try to do the division operation and it exits. In fact, we don't have any printout even from this system out println statement. At that line, we'll get an arithmetic exception, division by 0, and the program exits. So there are ways to solve this. Basically, we can use a print statement, an if statement. However, we can also use exception handling. So we can actually try executing the division, and here we have the statement that we had before that prints the division of number 1 with number 2. And if there was an exception, we catch that exception. We inform the user that an integer cannot be divided by 0. and we continue the execution of the program gracefully. So the execution continues in either case, either that there was no exception if number 2 was different than 0, or there was an exception and we inform the user about the error, and again we continue and we print execution continues, and the program basically behaves nicely. So again, I will show you how this runs in Eclipse. So with exceptions, again, if we try to run it, it will ask us to enter 2 integers. Let's enter the second integer to be 0. We are informed that the number cannot be divided by 0, and the execution continues. If there was no exceptional case, it still runs. So we can enter, let's say, 12 and 6. It prints that the quotient of the division of 12 with 6 is 2. The execution continues. So try catch allows us to try statements that may throw exceptions, like for instance division with 0, and we can catch that exception. We can basically have a handler for that type of the exception. We can do many things in this handler. We can actually inform the user of the error. We can ask the user to enter the correct value and set a flag to actually basically ask the user in a loop to enter values until the user enters the correct value. We can even exit with system.exit or return from the main method. Now we can also fix it with an if statement. So it is correct, we can check that the number is different than 0, and in this case the division will basically not be executed because we have this guard that basically stops the division before we actually do it, and it prints division cannot be 0, divisor cannot be 0. Now this is true in a main method like the one that we had here. We can actually inform the user easily with an if statement, and it's actually advisable that we do it that way. However, if we actually call a method to do the division and that method returns the result of the quotient, we have a problem, because again the method can only return a value up to what we learned up to now. Now we also learned that the method can throw an exception. So the method is defined correctly. We basically define the quotient method defined on the Cartesian product of integers with integers. It takes 2 integers and returns the quotient of that division as an integer. However, if the number 2 is 0, we cannot reduce the domain to actually not include 0. We can only use the predefined types in Java, which are whole numbers. All of them contain the value 0 for the second number. In either case, we have to return some kind of a value if the division was executed correctly, or we have a second output or a second possible output which is an exception. So basically the idea is that as the result of a division, and in this case we can consider that the quotient method is basically a function defined on integers with values in integers. This is like a function definition in mathematics. However, in exceptional situations it would return an exception, and this is returned when the second integer input is 0. So in most cases it will return the quotient. However, when the second input is 0, it will return an exception. Okay? So this is exactly what we are doing with this function. So now, just to give it a glimpse before we actually go over the theory and how to define exceptions, when the runtime error occurs in a called method, the called method may return not only an integer, but it may actually throw an exception. In that case, it doesn't return an actual value, it returns the fact that this was an exceptional case. So when we try to execute such a statement, like the method that we have here, in the block of the try-catch block, it will actually catch that exception. The execution stops the moment that we basically return an exception from that method. We catch that exception, and we can actually print information about the exception. In this case, that an integer cannot be divided by 0. Again, the execution continues gracefully. So we will print the execution continues by, in either case, that there was an exception or there was no exception, and we actually printed the result of the division. So there are multiple statements here that we will learn during this class today. First, that methods may actually return exceptions, and in this case we have to specify that the method quotient returns, it's possible to return an exception, it throws an exception. Inside the method we have a special statement, throw, that actually specifically throws an exception. So the division itself throws an exception, could throw an exception if the number 2 is 0. But we can also throw explicitly an exception. In this case we use one of the subclasses of the class exception, arithmetic exception, which is an object we created with the new operator and the constructor for arithmetic exception that takes a string, a message as parameter. So a method may throw exceptions, we can throw explicitly exceptions, and we can check if a statement that may throw an exception throws an exception with a try-catch block and catch that exception. So we learned a few things up to now. We learned the fact that a method, beside the fact that in most cases it returns a value, it may throw exceptions in exceptional cases. We can throw exceptions explicitly using the throw statement and create an exception as an object, one of the subclasses of the class exception, and that we can try executing statements that may throw exceptions, and we can catch those and execute a handler for that exception only if an exception was actually thrown. Okay? So exceptions basically enables a method to throw an exception to its caller, and without this capability we have to handle that exception ourselves and terminate the program. But the problem is that in this case, this method, if we actually pass as the second number 0, we cannot return anything, any integer that makes sense, because division with 0 gives us infinity, plus or minus infinity. So we cannot return just a simple integer to the main method. So here in the main method we print an erroneous result as the result of the division. So exceptions allow us to basically throw exceptional cases from methods to their callers and catch these exceptions and handle them in some way. Now, the same can happen in many other cases. As I said earlier, we can actually have errors in the program where the index of an element in an array is not actually checked to be within the range of the array. But it may also occur when we try to read, for instance, an integer from the command line and the user does not enter an integer. So in this case, basically this is a method, nextInt, that throws an exception and we need to catch it. Now in this case I enclose this within a do while loop. So by default the input continues as long as the user enters incorrect values. We try executing the statements, we try asking the user to enter an integer, we read that integer and print the integer that was entered, and we set the flag continue to false. This happens, we actually do not continue only if input.nextInt did not already throw an exception, because if there was an exception thrown, the execution is stopped and we execute the block in the catch block. So we catch exactly the type of the exception that was thrown, which was an input mismatch exception, is one of the subclasses of exceptions, which gets triggered when a user enters a value that is not an integer. And we inform the user to try again. We actually tell him that, or her, that the input was incorrect and an integer is required, and we read the next line. Next line, basically it's a method that allows the user to press enter, and we ignore that character that was entered. So again, in this case we continue the while loop If continue input is still true, because this line was not reached, then we ask the user again to enter an integer, read that integer. If the user enters an integer this time, we will actually set the continue input to false and exit the program. So let's actually try the programs that we saw up to now. So I showed you the first two programs, the quotient and the quotient with exception. If we have an if statement, we basically execute the same code, but now if the user enters 0, we actually print a nice message. If we have a method, that method may throw exceptions in exceptional cases, and then we have to catch that exception. So again, let's run this program in two ways. First, we will run it completely, the method threw the exception, and we code that exception. Second, we are going to actually execute this program with the debugger. So again, we start the program with the debugger. We will enter 1 and 0. And now since we enter 0, we actually entered in the debugger. In the debugger, we are going to enter within the step into the method. Since the number 2 was 0, when we try to execute that, it will actually throw an arithmetic exception. And you see, we skipped the system.out.println, the result. We jumped directly from the quotient method that threw the exception to the catch block that catches that type of the exception. And now we continue the execution. So in this case, we will print that an integer cannot be divided with 0, and the execution continues. Let's return to the Java perspective. And in the Java perspective, we execute the program that reads an integer, the current program that we read. So again, we are asked to enter an integer. Let's enter something that is not an integer. Maybe it may contain integers, but is not an integer. And we see again that it basically throws an exception that is caught in the catch block. We are informed that we have to try again. There was an incorrect input and an integer is required, and the program continues. If we do enter an integer, the number entered is 1 and the program exits. So again, without the try catch block, this would actually throw an exception and it will print an ugly message in the output, at least for a non-programmer. Now if we put a breakpoint, let's see what happens. So we'll put the breakpoint at the beginning of the program. Let's start the debugger again. Let's execute line by line. So in this case, we start the do while statement. Let's try again. So the user is asked to enter an integer. We will enter an integer. Let's enter A, B, C, a non-integer. And you see again it skipped all the statements between where we try to enter an integer and the catch block. Why? Because the next in method threw an exception of the type input mismatch exception, which basically skipped all the lines and went to the handler for that type of the exception. So again, we are going to be informed that we entered an incorrect line. And we continue the execution. So now if we do enter an integer, let's enter an integer 123. We will actually print that integer, set the continue to false, skip the handler for exceptions because there was no exception, and since the continue input is false, it exits the program and terminates. Okay. So, there are many types of exceptions. The reason why we learned object-oriented programming was graphical user interfaces, but it is also exceptions. So, first of all, we have the throwable class, which is a class that includes two subclasses, exceptions, and has two subclasses as direct subclasses, exceptions and errors. Now, errors are something that we cannot actually control. System errors are thrown by the Java virtual machine and represent the error class. Basically, it describes that there was some type of internal system error. They rarely occur. I only saw a couple during my programming days. If one occurs, there is little that you can do beyond notifying the user and trying to terminate the program gracefully. Usually it happens if you try to connect to some library, like for instance java.util, and that library does not exist. Somebody deleted it from the system. So there is nothing that you can do in that case. Basically, there is nothing that the JVM can do in that case. As I said, they rarely happen. They happen because of some kind of external issues, like a hard drive fails or is removed that contains sources or libraries that are needed by the JVM. There is nothing really that can be done. If we write a program, we will basically catch that error and the program exits. But they don't usually happen in general. The ones that we care about are exceptions. So they describe errors caused by our programs and some external circumstances, like the user enters a negative value, a file does not exist in the file system, and all of these errors should be caught and handled by our program. Either that we catch them explicitly or that we don't make mistakes in our program, because there are different kinds of errors. There are exceptions that are directly subclasses of the exception class. These are exceptions that we are required to check. We are required to put try-catch statements to catch these type of exceptions. And there are runtime exceptions. These are caused by programming errors. Like for instance, bad casting. We try to cast, like we did in the last class, an object to a student class, but not every object is a student, and it may be that the object is not a student, so we have to check with instance of operator to make sure that the object that we try to cast is of the type of the class that we try to cast it to, that we try to access an array element out of the bounds of the array, numerical errors like division with 0, arithmetic exceptions, and so on. Or that we try to access the data field of an object that was never initialized with the new operator, or basically the constructor. That is a null pointer exception. Or that we try to use a method with an argument that it's not defined, like for instance an illegal argument exception, and so on. So these errors, in order to avoid clutter of our classes, they are not required to be in a try-catch block. These are called runtime exceptions or unchecked exceptions, or it includes also errors. They are exceptions that do not need to be caught with a try-catch block. They basically signify the fact that the program may contain an error, a problem. So runtime exceptions, errors, and their subclasses are known as unchecked exceptions, and all of the other exceptions, which are basically the exceptions that are in the exception class, but they are not directly runtime exceptions or subclasses or runtime exceptions, are called checked exceptions, meaning that we are forced by the compiler to check and deal with these exceptions. In order to avoid clutter, if you think everything that we've wrote up to now, like elements, accessing elements of arrays, casting objects, accessing data fields within reference type variables, and so on, they should all be put within try-catch blocks. In order to avoid clutter, basically Java does not mandate that we have to put these unchecked exceptions within try-catch blocks. They usually signify that there is a problem in the program, and that problem should have been basically avoided with if statements or with correct programming. While the other exceptions, the ones that are not runtime exceptions or errors, they have to be put within try-catch blocks. That means that it's always expectable that we may have exceptional cases. Like for instance, if we try to access a file system, and we try to open a file that may or may not exist in the file system. In that case, we have to put the statement within try-catch block. We must put the statement within the try-catch block, and we should catch any kind of input-output exception that may be thrown. So unchecked exceptions are basically all the subclasses of runtime exception and error. They basically are statements that may throw error, may throw exceptions, but it's due either through circumstances that we cannot fix, like in the case of error, or errors in the program, which must be fixed with either if statements or correcting the program. So in most cases, these unchecked exceptions reflect programming logical errors, and they are not recoverable. For instance, if we try to access a data field for a reference type variable for a variable of a class type, and that object was never initialized, so then a null pointer exception will be thrown, because we are trying to access a data field for a reference variable that was never created. Similarly, if we try to access an element in an array outside the bounds of the array, an index out of bounds exception will be thrown. These are logical errors in the program, and they should be corrected in the program, either with if statements or with actually correcting the ranges of the indices and so on. So this can occur anywhere in the program, and in order to avoid overuse of try-catch blocks, Java does not mandate that we put try-catch blocks to catch unchecked exceptions. The other exceptions, they are exceptions that are not actually due to us. So, like for instance, input-output exceptions. So we have to deal with them. And there are two ways to deal with exceptions. One way is to actually try statements that may actually throw exceptions and catch those exceptions. The second way, if we don't know how to handle the exception in the current method should throw that exception. We call that declaring the exception. We declare the fact that the method may, in certain cases, throw an exception. We can throw such exceptions explicitly, or we can actually throw these exceptions using the internal Java core API. So we can catch the exception in the method that actually invokes that method too, and now we are required, again, because of the fact that the method signature throws exceptions and throws checked exceptions, we are required to put the invocation of that method within try-catch blocks. So let's go over all of these issues. Basically, we'll talk about how to declare methods to throw exceptions, how to throw exceptions explicitly, and how do we actually catch exceptions. One thing that you have to notice is the fact that there is a hierarchy of exceptions. So you have to catch the correct type of the exception that is thrown, or a superclass of the exception that is thrown. So for instance, we can say in the catch block that we catch a runtime exception, not specifically an input illegal argument exception or an arithmetic exception. Similarly, we can say that we catch exception, which basically catches any type of the subclasses of exceptions. So let's start syntactically to define every one of these parts of declaring, throwing, and catching exceptions. So every method must state what are the inputs, what are the possible return type, and of course what are the types of the checked exceptions that it might throw. This is called declaring an exception. The fact that the method may throw an input-output exception, or we can enumerate multiple types of exceptions that the method may throw. The method may throw an input-output exception or another exception and so on. For all of the methods that may throw exceptions, if we invoke them, we have to put them within try-catch blocks. And those catch blocks must catch either the superclass of all the exceptions that we are currently throwing, which is the exception class or the runtime exception class, or we must have multiple catch statements for every one of the exceptions types that is thrown. And the first catch statement that catches that type of the exception is the one that will actually be executed and continue the program. So we said that we can also explicitly throw exceptions. So when the program detects an error, the program can create an instance of the appropriate exception type and throw it explicitly using the throw statement. This is called throwing an exception. So exactly what we are doing, we are creating an object and we throw the reference of that exception. So this is a class. The exception could be any exception subclass, including the superclass exception. We can create the object separately and then throw the exception type variable, the reference type variable, or we may actually create the exception and throw it in one single statement. Usually the first one is the one that is preferred, because when we actually throw an exception, we know exactly that we are throwing that type of the exception. So here we actually define a method. Let's assume that in our previous class we actually defined the class circle, and in this class circle we had the modifier setRadius. What if the user enters a negative radius? Now we are bound by the signature of this method to actually set the radius to the value that the user enters. But if the radius is negative, we should in some way inform the user that he entered a negative radius. So in this case, beside the fact that the method would try to set the radius, we should also throw an illegal argument exception if the user entered the negative radius. So if the user entered the positive radius, then we set the radius to be the data field radius for the current object. This is a non-static method, to the new radius formal parameter. Otherwise, we should throw an illegal argument exception. The radius cannot be negative. So now the user will be informed that he entered a negative radius, and we declare it in the method definition. We say that the method setRadius. In exceptional cases, we throw an illegal argument exception. So how do we catch those statements, those exceptions? So if we have statements that may throw exceptions, these exceptions can be of various types: exception type 1, exception type 2, and so on. We can write a try statement that tries the statements that may throw exceptions, and if any exception is caught during these statements, we may actually check the type of the exception. So we check if it's of the type 1, we execute the handler for the exception 1. If it's of the type 2, we execute the handler for the exception 2, and so on. We basically catch the correct type of the exception and execute the handler for that correct type of the exception. Now, how do we actually catch an exception? An exception may be thrown of a certain type. We actually look at the stack and the methods that were currently invoked to find the catch statement that actually catches the type of the exception. So let's consider the following example. The main method invokes a method 1 in a try-catch statement which catches an exception of type 1. Method 1 tries invoking method 2 and other statements, and then basically this is within a try-catch block of the exception 2. Method 2 invokes the method 3 in a try-catch block that catches the type of the exception 3, and the method 3 may throw an exception. If the method 3 does throw an exception, then we need to catch that exception. The code stops. We don't execute a single statement after invoking the method 3, because we try to find the correct catch statement for the type of the exception that was caught. If the exception that was thrown is of the type exception 3, we continue the execution at this point. We basically process that exception, execute statement 6, return from method 2, execute statement 3, execute statement 4. We basically didn't catch an exception in this try-catch block in the method 1. We execute statement 1 after we return from method 1. We execute statement 2 and we exit. However, if the exception that was thrown is not of the type exception 3 or one of the subclasses of exception 3, then we still continue to find the right type of the exception. So we'll see if it's of the type exception 2. If it is, we continue the execution from this point. So we pop out the frame from the stack of method 3 and we basically go back to find which of the methods contains the catch statement for the type of the exception that was thrown. And we only continue the execution from that point forward. So if it's of type exception 3, we continue from here. If it's of type exception 2, we continue from here. If it's of type exception 1, we continue from here and we execute the rest of the statements in the program. So we unravel the stack and we also try to find the correct catch statement block for that specific type of the exception that was thrown. So Java forces us to deal with these checked exceptions. We basically either catch the type of the exception in the current method, or we throw the exception to the basically callers. So if a method declares a checked exception, an exception other than error or a subclass or the class runtime exception, we must either invoke it in a try-catch block or declare that the current exception is thrown from the calling method. So for example, suppose that a method P1 invokes P2 and P2 declares that it may throw a checked exception, for instance input-output exception. Then we have two choices. We either catch that exception and handle it in method P1 if we know how to do it, or we actually now write that P1 may actually also throw exception IO exception, which means that any method that calls P1 has to do the same thing, either catch that exception or throw the exception forward to its own basically parent method, caller method. Okay, so when I actually learned this topic of exceptions in my undergraduate many years ago, in fact I learned it that it's like a hot potato. An exception is like a hot potato. If we know how to handle it, we handle it ourselves with oven mitts or whatever. If not, we just throw it to the parent. Basically the parent method will have to deal with the hot potato. Sorry for the joke, let's actually see if there are any questions. So yes, we are recording today's lab, and the MPL is part of the labs and is basically graded as part of the labs. I already saw several students that submitted problems in MPL. We will deal with that during the lab today. Any questions about what we covered from exceptions up to now? Okay, so let's return. So let's see an extended example of exceptions. So we will create the class that we had last time called circle. This time we are going to create a circle with exception, which contains a data field radius and a number of object static variable. Circle with exception calls the other constructor for circle with exception using the keyword this of 1.0. Circle with exception that takes a double as a parameter throws an illegal argument exception because it calls the method setRadius with a new radius that is passed as a parameter. Now the method setRadius, it basically checks if the radius is greater than or equal with 0. If it is, then it sets the radius and exits, does not execute the else block. However, if the radius was negative, it throws an illegal argument exception, informing the caller method, which in our case was the constructor, that there was an illegal instruction, basically a legal case, exceptional case in the setRadius method. We don't execute any statements until we find the catch block that catches this type of the exception. So in this case, the method circle with exception, because it calls the setRadius with an illegal argument exception, it also declares the fact that it throws an illegal argument exception. The other methods are the same ones that we had in the class circle last time. So let's see what happens if we try to create circles with negative radius. So the first constructor is called with a radius of 5. That will succeed. SetRadius will set the radius of the object C1 with the radius 5. It will exit. It will return to the constructor circle with exception. That takes a double, and that returns to the main method. Meanwhile, we also incremented the number of objects with 1. This succeeded, and the number of objects is incremented with 1 from 0 to 1. Then we try to create a second circle with exception of radius minus 5. That calls the constructor, which calls the setRadius method, which throws an illegal argument exception because minus 5 is not greater than equal with 0. So that in that moment the program stops. We don't increment the number of objects in the constructor that called setRadius that threw the exception. We continue throwing that exception. So in the main method, we basically are stopped in the second constructor and we continue the catch block. We catch that exception. We inform the user that there was an exception by printing the toString method of the exception, which in this case it basically prints there was an illegal value for the radius, and we continue the rest of the program. So the number of objects that actually get created is only 1. Although the next circle is actually of a positive value, it will never be created because we stop the execution at the second constructor. Nothing gets executed past the point that if there is an exception until we reach a handler for that exception. Okay? So I will actually show you this program. This is circle with exception as we saw it declared before. Basically the constructor invokes the setRadius method. The setRadius method, if the radius is not positive, throws an illegal argument exception. And in the main method, when we try to create the second circle, we will throw that exception and we catch it. We print the exception and we print that the number of objects created is only 1. So if we run it, we see that the output of system.out.println exception, this is an illegal argument exception with the message radius cannot be negative, and the number of objects that we created in this program is only 1, which is basically the first one that was created. The reference C2 is null. It was never actually initialized to any circle because the circle had a negative radius. Okay, so this is the circle with exception program that we have in the lecture notes. I want to note that all the programs that you have in the lecture notes are directly executable. So you can actually practice either by writing them or actually just copy them from the lecture notes and run them. Now, it is possible in certain cases that we rethrow the exception. This is actually basically a common procedure to actually catch the exception and throw it again if we still don't know how to actually handle it in the current case. So there are try-catch statements that catch the type of the exception, and then if we don't know how to handle it in this case, we may handle it partially, but then we can throw it again. And now we throw it to the parent to deal with it. The try-catch block also has a finally statement. The finally clause always executes when the block exits, in either case that there was no exception or that there was an exception. So the finally block will always be executed, no matter if there was an exception or not. So the statement that I made earlier, that the moment that an exception is thrown, is the program stops. Yes, it does, but that's not totally completely correct. In fact, on the way back to the handler for that type of the exception, we execute all the finally blocks. The finally blocks are used for cleanup code. Even in the case that there were exceptions, we should still clean up the memory for the current program. So for instance, if we had, like we will learn today, a print writer that writes the output to a file, we should close that print writer. So we should have code that cleans up basically the memory explicitly that we actually used in the try statement. So even if the current catch statement is not executed, the finally block still gets executed. It always executes. It's for cleaning up the memory when we exit exceptional cases. So when should we use exceptions? Basically, we should use exceptions when we are required to. Like for instance, in input-output exceptions. If we read from a file or we write to a file, we are required by the fact that those methods that open files, open scanners to files, we use the same class scanner to read text from files that we use for reading from the input stream in the console or the command prompt. We have to use try-catch blocks to basically execute those commands to read from files and then to catch if there are exceptional situations. So exception handling separates this kind of error handling from normal programming tasks, thus making the programs easier to read and modify. Now, one thing that you have to be careful about is the fact that exception handling requires more time and resources, because it initializes new objects, exceptions, and rolls back the call stack to propagate these errors to the caller methods. So it takes time to create these objects and more memory to create these objects, to put these objects in memory. So we have to be very careful when we want to use exceptions, as opposed to when we basically can just use if statements in our program. So if an exception occurs in a method, if you want the exception to be processed by the caller, you should create an exception object and throw it. If you can handle the exception in the method where it occurs, then there is no need to throw it, and you should do it yourself. So I want to make clear that exceptions should be used only in the case that we don't know what to do in that exceptional case, or we don't know what to return from that exceptional case. So we have to be very careful about when to use exceptions versus when to use just normal if statements. So you should only use exceptions when you deal with unexpected error conditions. For instance, if you want to print the value of some reference variable, and you don't know if that reference variable was instantiated probably by the caller to the method or by anyone else, you shouldn't do it with a try-catch block. It's better to replace that code with an if statement that checks if the reference variable is different than null. If it's different than null, you would just execute the code normally. You will print the reference variable with the toString method. Every method must have, every object that is created must have a toString method because it's inherited from the class object. We learned about this last class when we talked about inheritance. Else, we should just print that the reference variable is null and we are not printing the value. So the execution of these two pieces of code will produce exactly the same output. The difference is that the first code, the try-catch block, if the variable was null, will create another object in memory for the exceptional case, the exception null pointer exception, and then it will catch it and print the result reference is null. So the first part of the code is less efficient. It is inefficient because it uses more memory unnecessarily, and it actually takes time to create this object in memory. So use exception classes anytime you actually need to throw an exception, like input-output exceptions. Now, there are a lot of classes in Java for exceptions. We saw null pointer exception, arithmetic exceptions, illegal arguments exceptions when the methods do not get the values the arguments that they need. So you should use the classes in the Java API whenever possible. However, if you have an exceptional case that is not defined in basically the set of classes in the Java API, you can also extend the class exception and any one of the other exception classes with your own defined classes, user-defined classes. So you can define your custom exception classes if the predefined classes are not sufficient. You can define a custom exception class by extending exception or any other subclass of exception that you like. So for instance, let's assume that we are not happy with invalid argument exception. We want actually to create our own subclass of exception for invalid radius exceptions, for circles with negative radius. So in that case, we can actually implement our own invalid radius exception that extends the exception class. Is a checked exception because it's not a subclass of runtime exception or error. We define the data field radius and the constructor invalid radius exception that takes a double radius formal parameter and calls the superclass, which in this case is the exception class, the superclass constructor with a string saying that this is an invalid radius with a negative radius. In addition to that, beside the fact that we have this string data field in the class exception, we also basically set the radius data field in the current exception class invalid radius exception with the radius formal parameter. And we have an accessor for this radius field to return the negative radius, the value of the radius. So how can we use it? In the same way that we used the invalid illegal argument exception before. Basically, we define a new class circle with radius exception, our own type of exception, and this class has a data field radius like the circle class that we had before. The constructor one of the constructors will take the new radius as a data field. As a formal parameter, we call the method setRadius with a new radius value. The new radius, the setRadius method, will take the new radius, and if the new radius is positive, it sets the radius. Otherwise, it throws an invalid radius exception. So now the invalid radius exception is actually a checked exception. So we are required to actually throw an invalid radius exception. This is a checked exception. Our method must throw that type of the exception because we had to throw that type of the exception within the method without a try-catch block. So now in the constructor itself, we basically have to catch that exception or to throw it ourselves. In this example, I chose to actually catch it in the constructor. So I will still create a circle with radius exception even with a negative radius by actually creating a circle with radius of 0. So I try executing the set radius, but if the new radius is negative, I will catch the invalid radius exception and print the stack of this exception. So what exactly is this method print stack trace? So the exception object contains basically the entire state of the current stack. What is the method which throws that exception? In our case, the setRadius method. What line of the code throw that type of the exception, which in our case is the throw new invalid radius exception? In what method was the parent method, the caller method for the setRadius method, which is in this case the constructor circle with radius exception? In which line that method was called, the setRadius method, and which method called this method, and so on, which is in fact the state of the stack. It tells us what is on the top of the stack, what is below the frame on the stack, and so on. So let me also show you this example, the circle with radius exception. So circle with radius exception basically has the constructor for invalid radius exception is the class invalid radius exception, and has the method, the constructor for circle with radius exception, which takes a double and calls the method setRadius, and basically has the setRadius that throws that invalid radius exception. The only other method that I use in this case is the main method that creates a circle with radius exception of a negative radius. So in this case, if we run it, it gives us the result of the print stack trace. So this is the print stack trace. The stack trace tells us what is the error that was basically obtained. In our case, there was a negative radius, and it gives us the stack. That the method that actually gave us that error is the setRadius, and the error was triggered in line 36 of the program, which is in fact this line. The method setRadius was called by the constructor method init in line 25, which in this case is this line 25, and the constructor was called from the main method in line 40, which is this. And if we actually run this program with the debugger, it will actually show us exactly the same trace. So let's put a breakpoint when we try to create a circle with radius exception, start the debugger, start executing, step into that method, which in this case it calls the method setRadius. Let's step into that method, which will check if the radius is positive. It's not, and now it will throw an exception, and that exception is caught in the constructor circle with radius exception, and it prints that stack trace that you saw before. And if we continue the rest of the program, which is basically just exiting the program after the constructor. Let's return to the Java perspective from the debugging perspective, and now we will learn how to read and write files in Java. Okay. So text input output. Basically, we can read and write to files the same way that we do it in the command line, the console, using a scanner and a print writer. Now, there is a class called file that is intended to provide an abstraction to deal with most of the machine-dependent complexities like operating system file paths, delimiters, machine basically dependent issues, and so on. So the file name is given as a string, and the file name it's either the file name within the current working directory, basically where the program is currently started, or is a relative path to the current working directory. Is basically a path where you are given from the current directory how to get to that file, either by using the directory names and then the delimiter that you use, / for Linux or Unix based machines, and / for Windows. And then you have to basically specify the file name, or you can give the file name, the path to that file using an absolute path. An absolute path is basically how do you get to that file step by step from the root of the operating system. So for instance, in Windows it would be the drive C : / and then how do you get to that file. And you can get easily those, basically the information about the file, by actually, let's open one input file and look at the properties. The properties will give you both of those paths. It gives you the relative path and it gives you the absolute path as the location of the file. Be careful that if you are using / in Windows, you will have to escape it. You need basically 2 / when you actually write it in the program, because you basically need to, the / is for escaping the next character, and if you escape the next character, you have to escape, if you want the / character, you need to escape it with the / character. So you need twice that /. Okay. So let's see a couple of examples. Let's return to the lecture notes. So the file class takes either the path name to the file as a string, or takes the directory in which the file exists, which is the parent, and then the name of the file as the child, or takes the parent as a file object and the name of the file as a string. And we have methods that basically deal with that file. We can check if it already exists in the operating system. We can check if we can read from that file, if we can write. If it's a directory, so a file object may stand for a directory, may also stand for a file. We can check if it's a file. It returns true if it's a file, or false if it's a directory. We can check if it was created using an absolute path from the root of the operating system. We can check if it's hidden in the operating system or not. We can get the absolute path, we can get the canonical path or the relative path from the current directory. We can get the name of the file, we can get the path of the file, we can get the parent of the file as a string, basically the directory in which this parent was created. We can check when there was that file last modified, if it was deleted, or actually we can delete the file and return a true value, and we can rename the file. Now, these are all methods that are usually covered in an introductory course like Computer Science 0, or basically Introduction to Computer Science like our CSE114 class. If you didn't take that class, is not a problem. All of these methods basically are self-explanatory in the lecture notes. You basically can try them all to see what the output is. So the file object encapsulates the properties of the file, but it doesn't contain methods to read or write from that file. We can actually perform input-output, read and write, using a scanner object, the same way that we would do it for an input stream from the system, and by using a print writer, the same thing that is a system.out that we use to print in a command line. So let's start with reading. We can create a scanner object either by passing in a file object or a string of that file. We prefer the first method because it actually we can create a file explicitly, check if it exists or not, and then try to write to that file. The close method is important. It basically allows us to close the input stream once we are done with it. And then we have methods to check if there exists an input in the stream, and then all the methods that we already learned from the scanner class. Next for reading the next string, next byte to read the next byte, next short to read the next short, next int to read the next int, next long to read the next long, next float, next double, and next line to read the next line. And you can use a different delimiter to basically read a string using that delimiter. By default it uses space, and I advise not to change it. And here we have an example. Suppose that in our file system we have a file scores, and the file scores contains names of people and their score. So in our case this would be John 100, Paul 100. Okay? And we want to read from that file. We will do it directly in Java. If the file is directly in your project, then you can just open it you can create an input file, java.io.file for that name. You can create a scanner for that file object. And while the input still has next inputs, we can read the first name with input.next. The file has to be in this format. And we can read the score and print the score and the name in the output stream. So if we run this program, it basically reads everything from that file, scores, and prints the score. Okay? That's exactly what this program does. And you can actually take it from the lecture notes as is, create a file scores with the name of the student and the score, one per line, and then basically read the entire file. How do we print to a file? You create a print writer for that file, and then use any one of the print methods to print the type of the output that you need. Basically you can print a string, a character, an array of characters, an int, a long, a float, a double, a boolean, and so on. So again, we are going to do it directly in Java. So write basically creates a new file, in our case new scores2. You can name it anything you want. Basically it will create the file with the corresponding score. And if the file already exists, then there are two options. You can delete it, or you can basically inform the user that you cannot write to that and exit the program gracefully. You can create the file output stream. So in our case, it's basically we create a print writer, and you can print anything you want in the file. In this case, I'm printing John 100, and I close the output. Always close the output. This will flush from main memory the output to the file system. If you don't do it, you may actually do not get the output correctly in the file system. Java does not check that you are actually flushing the file, you are actually writing from the main memory to the file system your outputs. So you may actually not get the correct output if you don't close the file. And that is basically everything for today. Now, in order to help you with the lab, I also implemented all the problems in the lab, and I will show you those problems in a couple of seconds after we stop the recording for the lecture. and then we will actually record everything from the lab. I will explain to you what this does and do that. So let's